Okay, good morning, everyone. Welcome to today's synchronous session. And I apologize na hindi tayo nakapag-meet noong Tuesday, no? Pero next week, next week is Holy Week pala, no? So, hindi tayo mag-meet noon. Tapos, in the following weeks, balik tayo sa Tuesday schedule natin. Okay? And by the way, i-remind ko lang kayo, yung exam natin April 9 na pala, no? That falls on a Friday. So, check lang natin yung course guide natin. Nakikita naman yung screen ko, no? Chat. Narinig ba ako? Hello?
Yes, sir.
Okay, thank you. So, check lang natin yung course guide natin. This is what our schedule looks, no? April 10 yung take-home exam natin. Okay? So, we're in this, nandito tayo ngayon, Diffusion in Solids. And actually, na-upload ko na yung 2 handouts para dito, no? So, yung ano na lang kulang, yung podcast. Although, most sa calculations nandito naman sa diffusion in solids, no? Ito, wala na tayong synchronous session for nucleation and growth and elements grain boundaries kasi wala naman siyang masyadong calculations involved, no? So dito lang tayo sa diffusion solids. So after Holy Week, yun yung exam date natin. So it's a take-home exam. I-release siya through OVLE. Tapos it's a timed exam, I believe. At take-home exam lang pala siya. So from April 10 to April 12. Okay. Tapos I think we're on schedule naman, no? Tapos yung mga online quiz natin, I will make them available later today, no? Yung quiz naman, it's a very short quiz lang, no? Multiple choice siya and it will be through OVLE na din. So, hindi siya masyadong mahirap, no? So, uh, wag kayo masyadong ma-stress doon sa mga quizzes natin.
Per time po ba yung online quiz natin?
Ano yun ulit?
Time po ba yung online quiz natin?
Yes, time siya. I think kasi short lang siya, baka 1 hour lang yung time niya. Parang 5
Sige,
to
sir.
10 items lang.
Sige po.
Okay. Okay, so let's start with this problem, no? So meron daw tayong isang steel gear, tapos gusto natin i-improve siya by hardening its surface. And again, I think nasa MetE176 nyo dito, no? This process is known as your case hardening process. And specifically ito, you are using carbon, no, to harden the surface, which is the main way we can harden steels, no, increasing the carbon content. Okay, so sometimes this is known as carburization, and meron tayong sinusupply na external carbon-rich gaseous atmosphere at an elevated temperature and constant temperature. So it's elevated para mas mabilis yung diffusion niya, no? So if it were not elevated, then baka it occurs at a very slow rate. And you can calculate this on your own, no, using yung ano natin, yung pre-exponential na diffusion term, yung gagamit tayo ng Arrhenius equations, and parang makikita nyo doon na kung low temperature, parang aabot ng ilang days bago makapag produce kayo ng any appreciable diffusion, no? So you can work with the numbers and you'll see that at room temperature or normal or unelevated temperatures, mabagal talaga yung diffusion ng diffusing species into a metal, no? Okay? So, you can do it this way, yung carbon-rich gaseous atmosphere, yung i-purge mo or i-expose mo yung metal to that carbon-rich na gas. Pero sometimes, in practice, pwede din i-expose mo lang yung metal mo in a bed of, carbon. So, minsan yan yung ginagawa nila. No? So, meron kayong parang charcoal or carbon black, any carbon-rich na na substance, tapos kahit solid siya tapos parang ilalagay mo lang yung metal mo doon so such that mag-absorb siya ng ano nung carbon, no? Pero in that case, since solid yung parang bed mo, hindi as ano bang term, hindi as homogeneous yung magiging case hardening mo, no? Pero in practice, yun yung mas madaling gawin. Okay? So pero in this problem, ginamit nila is carbon gas, no? So the initial content of the steel is 0.2% weight percent. So that's a hypoeutectoid steel siya, no? Our eutectoid steel is at somewhere around zero point 0.8, no, or 0.76. So anything lower than 0.76 is hypoeutectoid. Okay? Whereas the surface concentration is to be maintained at 1% na weight. For this treatment to be effective, a carbon content of zero point 0.6, sorry, must be established at a position of 0.75 below the surface. So let's for this problem, we are to specify an appropriate heat treatment in terms of temperature and time for temperatures at 900 degrees Celsius, 950 degrees Celsius, 1000 degrees Celsius, and 1050 degrees Celsius. So let's use the data for the diffusion of carbon in gamma iron, and it should be provided here now. Okay. May diffusivity bang binigay? Okay, sorry kukunin natin yung diffusivity dito. Okay, since this is oh no, this is nitrogen into carbon, so this is not it, no. Hanapin lang natin. Walang binigay dito sa problem, no? Use the diffusion data for the diffusion carbon in gamma. Okay. Mukhang doon sa example 1 natin kukunin. So let's just take that data, no? So this is it. Hindi, nitrogen din to eh. Anyway, siguro na nasa slide naman yun. So let's just proceed with the no, problem. Saan tayo? Okay. Example 4. Sorry. Okay, ito class, no? So gagawa daw tayo ng heat treatment plan. So when we do heat treatment plans, it's usually in terms of time and temperature. So for example, my heat treatment plan is 900 degrees for 2 hours, 2 hours na soaking time. So we call the another term for yung yung amount of time na binibigay nyo during the heat treatment process is soaking time, no? So we are soaking our material in a particular atmosphere for a particular amount of time. Okay. So again, when we specify heat treatment plants, it's in terms of a soaking time and a soaking temperature. So yung soaking temperature is just the working temperature na pipiliin natin. So dito, given yung mga working temperatures, then ang kailangan lang natin is to compute for the appropriate soaking time, no? So if we were to do this, then we use the the yung case hardening na equation, tama? Since we already know na i-case harden natin siya, and then ang equation na gagamitin natin is the C naught C1 minus C naught minus CX over CS minus CX is equal to C naught etc. Okay? So, let me change my para mas makita natin siya. And we write our equation now. We have CX, sorry. CX minus CX, and this is the composition at a particular na X position, no? CX minus C naught over CS, and this is the surface concentration minus C naught, where C naught is your composition of the metal, tapos is equal to 1 minus the error function, and error function is a ano siya no, asymptotic na function wherein symmetric around the origin siya. So parang ganyan yung error functions. Okay? So we do error function ng position x, and position x usually in terms of millimeter siya no. Kasi yung penetration depth naman when we talk about diffusion is just small no. And sometimes microns, it's in the micron level no. Pero if we are using SI units, i-meters na lang natin sila lahat. Okay? Then we have 2 times square root of d, where d is the diffusivity t. Okay? So, what do we know? Ang alam nating na values from the equation is that Cx is the composition of the initial composition of, or Cx is the composition at yung certain depth, no? And sabi sa problem, and if you look back at the problem, sabi sa problem, Cx is 0.6. Tama? So this is 0.6. Tapos ang Cs natin or the surface is 1. Tapos yung content ng steel which is C naught is 0.2 and we are doing a depth of 0.5 no. Okay? So i-write down natin siya. So ito this now becomes Cx is 0.6 minus 0.2 over yung CS natin is 0. CS is 1 minus C naught is 0.2 again. So that's 1. And ito class, notice na this was in percentage, no? Pero ang nilagay ko lang siya as is 0.6, 0.2, 1. Hindi ko na siya pinaction na 0.006 and 0.002. So hindi na siya necessary, no? Pero if you want, you can also do that. Pero as long as your units are consistent when you place it in this term here, yung first term natin, kasi this is just one term, no? As long as it is consistent, then you should get the correct answer, no? Kasi dito magiging unitless value lang naman siya. This is a concentration unit over a concentration unit which gives you a unitless value. So it should cancel out. Okay, pwede nga ang gawin nyo is kunwari you assume a 1 kilogram basis tapos naka-kilograms nito. It wouldn't really matter, no? You will still get the right answer. Okay? So, to error function. And ang ituturo kong method ngayon is through Excel lang, no? So, hindi na tayo gagamit ng tables. But if for some reason wala kayong Excel or spreadsheet program, then you'd have to use the table tabular values. Tapos you'll probably do some form of linear interpolation. Okay? So we are doing this at a depth of 0.75 millimeters. So 0.75 millimeters is 7.5 times 10 to the negative 4, no? Tama? Kasi 0.70 millimeters is 10 to the negative 3. Okay? I think that's correct. Tapos over 2 times square root of d times t. Okay? So ang unknown natin is actually nasa loob ng ano natin, no? Sa loob ng error function. Okay? So if nasa loob siya, hindi masyadong straightforward yung ano, no? Yung calculation in Excel. Pero meron tayong mga tricks na pwedeng gamitin, no? Okay? Okay. Pakita ko lang to. Sige, mamaya na natin i-solve to, no? Since this is nasa loob pa naman siya, hindi muna natin kukunin yung diffusivity. Nasa table pala tong D na to, no? Itong diffusivity. Okay? So, evaluate muna natin siya. And I could just open Excel na lang siguro, no? Para mas maganda ata kung naka-Excel tayo. Okay. Excel. Okay. Kita na yung Excel, no? So, I could do CS, C naught, CX, tapos X. So, let's do CS is equal to 1. 1 lang to. C naught is 0.2, CX. No, sorry. Asa tama. Tapos CS is 0.6. Tapos depth natin is 7.5, 0 points. Sige na nga. 7.5 times 10 to the negative 4. 1, 2, 3, 4. Tama. Okay? So, gawin natin yung left-hand side muna ng equation. Gawin ko lang ganito, no? Left-hand side is CX minus C naught divided by CS minus C naught. Okay? So maganda kung ginawa niyo siyang ganito, guys, no? Kasi if you do it like this, if in case kunwari nagkamali kayo ng input, pwedeng i-change nyo lang yung input dito sa itong different values na to. So we get 0.5. Yung right hand side ng equation natin is equal siya dun sa ano, no? Kung babalikan natin, equal siya sa 1 minus error function. So ilipat na natin yung plus 1, tapos divide na din natin ng negative 1. Tama? So ang gawin natin is ilipat na natin to si plus 1. Transpose natin si plus 1. Tapos para matanggal tong negative, i-divide na rin natin by negative 1. Okay? Para matanggal tong negative na to. Okay, so we do ito plus 1. Pwede siguro step by step na lang. So plus 1 tapos times negative 1 na lang. Negative nito. Okay? So I should have negative 1 and this should be equal to yung right hand side natin is
Sir, hindi po naka-share screen yung Excel.
sorry. Ito. So we can do 0.5. Ito, ginawa ko lang negative times yung ito plus 1. Okay, so yung right hand side ng equation natin is ito na yung error function ng x over 2 times square root ng dt. Tama? Parang ganyan siya. Okay? So, pagka ganito yung case, meron na tayong left-hand side, i-equate na lang natin siya sa right-hand side. And pagka meron tayong error function na ganito, then the inverse of the error function of 1.5 is equal to yung nasa loob. Okay? So, if I get inverse nito ng negative 1.5, equal na siya dito sa x over 2 times square root ng dt. Parang ganun kasi yung gusto natin mangyari, no? Parang ganyan. Unfortunately, si Excel, wala siyang ganitong, this does not exist, no? Etong earth.int. Meron tayong earth, ganyan. We can get the error function of kunwari yan, but we cannot get walang function na earth.int such that yung makukuha natin to. Parang ganyan. No? So, means wala tayong earth.int, gagamit tayo ng property ng error function such which is directly related siya sa yung gamma distribution, no? So error function has a or meron siyang relationship with the inverse function, no? And the way we do it is we use this formula, no? So gagawin natin is kunin natin yung square root ng gamma inverse of the Earth Z na gusto natin mahanap, which in this case is yung 1.5, no? Tapos comma, and this is a constant, no? We use 0.5 and we use 1. So itong dalawa, fixed na to. Itong 0.5 and 1, hindi nyo na babaguhin. Ito na lang yung kailangan nyo hanapin. So ito, equivalent to of finding the inverse of the error function of whatever p value we are trying to get. Okay? So let's use this equation. Balik tayo sa Excel. So the equation is square root ng gamma inverse of this value, and we use 0. Ano ulit yun? 0.5 tapos 1. Again, ito constant na itong dalawang to. Okay? Oh. Gamma inverse. Ba't siya nag-number error? Let me just check my ano, no. Mali ba akong na-input? Wait lang guys. Mali ba to? (0.6) D3 minus 0.2 divided by D6 po dapat. Okay, may comment si Larnie. D6. Hindi, ito kasi is, ano pa lang to, Larnie, no? Yung sa left-hand side without the 1. Kasi may 1 plus, 1 minus earth pa to eh. Ng ganyan. So, lilipat pa natin si 1. Tapos divide natin by 6. Okay. Ba't tayo nag-plus? Dapat magma-minus tayo, no? Kasi since 1 siya. Sorry guys. So since 1 to dito sa right hand side, pag nag-transpose tayo, dapat minus 1. So we should get 0.5. Tama? Okay. Thank you. So dapat ito. Actually, same lang sila, no? So ang nangyari kasi is itong 1, lilipat natin sa kabilang side. So dapat minus 1, 0.5 minus 1, tapos divide natin by negative para positive na yung earth natin. Okay, so this is the equation. Square root ng gamma inverse, ganyan. So, and just to be sure, pwede tayong para lang tama. If you want to check, no, kung tama yung ginawa nyo, gawin nyo lang is, kunin nyo lang yung earth nito, and it should return the same value, itong z value na to. Okay? So, we get 0.477 is equal to itong ano, no, itong x over 2 square root of dt. Okay, so we know our x. So if we were to manipulate this, then this will become dt is equal to 0.477 divided by x, and we multiply this by 2 times ganyan. Tapos itong buong value na to is-square natin. Tama? Parang ganyan yung mangyayari dyan. Kasi tatranspose natin si 2 on this side. Ay, sorry. Baliktad. Magiging x over, kasi lilipat pala natin. No? Magiging x over yung divided by 0.477 pa. Parang ganyan. Tapos is-square pa natin kasi square root of dt. So, isa-isayin na lang natin. So, this becomes, eto, itong value na to divided by, sorry. It's x, which is the position ito, divided by 0.477. Tapos, we divide this by 2 again, no? Okay? Tapos kunin natin yung isa-square na natin siya para makuha yung dt kasi naka-square root si dt. So, square natin siya, kukuha natin yung ganyan. Okay? Now, if for us to get the value of d, kailangan natin gamitin pala tong ano, no? Kaya ito gagamitin natin. So, for our metal, ito yung papiliin natin ano, no? Um, d value. So, we have C. We have our diffusing species is carbon. Tapos, it is diffusing into the host metal gamma. Kaya gamma yung pinili natin because, and actually, kailangan natin gumamit ng phase diagram pa nito, no? So, let me just show you what I mean. So, if I do phase diagram of Fe3C. Okay. Let me just copy this phase diagram now. Ayan, papakita ko lang sa inyo kung bakit gamma yung pinili natin class, no? Kasi if we do a 0.2 is pre-eutectoid or hypoeutectoid condition. So nandito siya somewhere dito, no? So ang temperature na pinili natin was 900 up to 1.5, tama? Yun yung binigay ng problem. So it's somewhere along this region, no? So if you notice, it's well within the austenite region, yung 900. So that's somewhere dito siguro. And for 0.2 carbon and even yung 0.6 carbon, no? Kasi yung ano natin, 0.2 yung initial na carbon concentration pero it can go higher, no, because of the diffusing na carbon content. So pwedeng mag-go higher pa yung carbon concentration niya and pwedeng magbago tong eutectoid line natin, no? Or yung itong we call this as the A3 line, no? No, sorry. This is the A1 line pala, sorry. This is the ACM line. Okay? So, pwede magbago siya pero since pag nag-increase siya to 0.6 kunwari, nandito pa rin tayo sa gamma region. Okay? And baka mas makita nyo pagka inaise ko dito. Okay, so what I mean is if I take a line, so from 0.2 kunwari, somewhere dyan, it is 900 is somewhere dito. Okay? So dito 900, it is in the gamma region. Tapos kukuha ko 0.6.
Pero hindi ko yata nakashare yung
Ito. Sorry. Thank you. So ito, if I draw a line, ito siya, nandito yung 900, no? So you are well within the gamma region. Tapos pag nag-draw ako ng line ng 0.6, it's also within the gamma region, no? And di ba ang mangyayari kasi is the diffusing species is from kung ito yung carbon natin, ito yung kunwari metal piece natin, nandito yung carbon rich gas. So this is your carbon rich gas. Tapos kung ito yung carbon rich gas, yung concentration profile nito is something like this, no? Parang ganyan. So this is the 1%. Tapos ito is 0.2%, which is the original composition of this. And yung 0.6 is somewhere at a particular amount of time. Nandito siya, no? 1.7. 1.7, sorry, 0.75 ata. 0.75 millimeters. So, nandito yung 0.6. Parang ganyan siya. At a particular t equals x. And this curve can change, no? Pero the point being is at any point in between 0.2 and 0.6, dapat within the gamma austenite region kayo parating. So, this only becomes complicated when the temperature you choose is actually, kunwari ang temperature na pinili natin is lower than the austenitizing temperature, no? Meaning this line here. Kung lower siya than the austenitizing temperature, then you can have your alpha and posibleng hindi na natin magamit yung hindi na natin to magamit itong value na to. Itong carbon diffusing into alpha ferrite, no? Into gamma austenite. Pwedeng etong carbon into alpha ferrite naman gamitin natin. And since mix siya, medyo complicated, no? Hindi ata natin masosolve yun. Okay? So, for now, since hindi naman siguro kami magbibigay ng problems or definitely hindi kami magbibigay ng problems wherein mixed yung host phase natin, no? So, always, ang bibigay naman natin is sure na yung host phase natin is a constant na or a single phase na region. Okay? So yun yung kailangan yung bandayan class, no? Kung ano yung diffusing species, kung if you are given a table like this, always identify kung ano yung diffusing species, tapos kung ano yung host metal na yan. Okay? Because we have different host metals, no? So even iron can have different na allotrope. So at lower temperatures, alpha probably yung ano, no, at lower than 727, which is the eutectoid temperature, then you should choose alpha. Okay? Yung alpha iron. Okay, so for this case, we are given ano, no, gamma Fe. Then ang gagawin natin is let's take note of the ano, no. Ang importante dito is itong D naught, which is the pre-exponential. Tapos itong activation energy, which is in terms of kilojoules per mole. So hindi na natin gagamitin tong electron volts per atom, no, kasi naka-joules naman yung ano natin. Okay? So meron palang estimate na din dito, no, and this is for 911. Pero we can still compute it on our own, no? On our own. So let's compute that. So naalala nyo ba yung formula? Pwede pala ako mag-ano dito. I forgot that Excel also has ano, no. So, di ba ang formula ng if you are given if you are not given the exact value of D, pwede actually natin makuha yung D value using using an Arrhenius type equation, no? So that's D naught is equal to EXP times negative Q, which QD over RT. Okay? So, again class, ito yung tinatawag natin na ano, no, na Arrhenius type equation, and most equations that is related to ano, no, parang na may form of rate involved, or kahit mga probabilities, no, they usually are in the form of an Arrhenius type equation. Pag nag-annealing tayo, ano pa ba, yung annealing natin, yung recrystallization computations, they all use this Arrhenius type equation, no? Nagbabago lang yung constant na to, tapos magbabago lang yung activation energy na to. By the way, nag-MET19 na ba kayo? MET19?
Ngayon pa lang, sir.
Okay. Na-encounter nyo na ba yung ganitong type of equation, yung Arrhenius type?
Last sem lang po yan, sir, yung na-introduce lang sa 11, MATI 11.
Matila.
Kahit sa MATE 11 pala in-introduce na to, no? Okay? So you'll be seeing this a lot in this dito sa course na to, itong Arrhenius type equation. Okay? So if we use that, then our pre-exponential is equal to, and balikan lang natin yung slide, no? Ano yung pre-exponential natin? Our pre-exponential is 2.3 times 10 to the negative 5. Tapos yung activation energy natin is 148. Okay? So let's do that. D naught is equal to 2.3 times 10 to the negative 5. Negative 5. And lagay ko na equal sign para. 2.3 times 10 to the negative 5. Yung QD ko, which is the activation energy, is equal to, ano yung activation energy ko? That was 148. So that's 148. Tapos since it's in kilojoules, gawin natin is 148,000 joules para maging joules siya, no? Joules per mole. Tapos ang gagawin natin R is in terms of R is the gas constant, no? And kung joules siya, it's 8.314 joules per mole Kelvin, no? Tapos yung temperature natin is, um, this now becomes a, ano, no? This is a varying, ano na siya? Varying variable, kumbaga. Okay? So, kasi we have multiple variables, no? So, pwede tayong gumawa ng, it's a variable, lagay lang tayo ng isang variable na 900, no? Tapos ito, papalitan natin. No, sorry. So, magandang strategy dito. Pwedeng gawin natin is, di ba, heat treatment profile, plan pala. Heat treatment plan, we have time, temperature, and time. Okay, so pwedeng gawin natin ganyan. 900, ano nga yung hinahanap natin? We have 900, 950, 1,000, and 1050. So 950, and I can just drag this, no? 1050. Tapos, ang hanapin natin is yung time in in seconds yung makukuha natin, no? Tapos convert na lang natin to appropriate number of days. Okay? Okay. So, gawin natin equal to sa yung D natin is just equal to this one multiplied by exponent, and yung exponent natin sa Excel formula is just exp, no? Exponent ng negative of the QD divided by 8.314 divided by, and let's use this temperature, no? Ito. Tapos ang gawin natin is para pag nag-drag down, if ever nag-drag down tayo, ang hindi magbabago yung ano natin. I doubt pala i-write ko na as one equation, no, para mas ano to. Okay. DT, i-divide ko na siya. Ang gagawin ko class is i-divide ko na diretso dito, no? So whatever I get here, i-divide ko na lang diretso sa ano. Okay? Para pwedeng ganito yung gawin natin. Equals, yung time natin is equal to this value divided by, since ang mangyayari dito is T is equal to this value divided by whatever D na makukuha natin, no? Parang ganyan. Maging E9 siya divided by whatever D na makukuha dito. Okay? So kung ganyan yung case, then this is equal to ito divided by, and let's just do a quantity, no? So open parenthesis, ito multiplied by exp, then negative QD divided by R divided by T. And this is degree Celsius plus 273 pa, no? Para maging Kelvin. Okay? Then, i-close lang natin lahat. So, we should get, and remember, ang gagawin natin is, naalala nyo pa yung MetE176 nyo. Yung i-fix natin to using F4 para pag nag-drag down tayo, para pag nag-drag down tayo, yung 900 lang magbabago. Okay? So, if we should get something that looks like this, no? And this is in seconds. Therefore, kung naka-seconds to, this time in seconds, divide natin by 3.6, no? So, ito divided by 3.6 gives us hours. In hours. Okay? Now, let's check kung tama yung ginawa natin. And same naman, no? So we have 29.3 hours, 15 hours, 8 hours, and 5.2 hours. Okay, and if we check, double check again, the same value, no? Okay, So I hope nag-make sense yung ginawa ko class, no? So kaya ko siya parang inayos yung formula para actually pwede kong ma-divide, pwede kong ma-drag down, no? Pero you could have very well done, pwede minano-mano nyo, no? Kunwari, eto times exp ng negative nito divided by r divided by kunwari 900 plus 273. Pwede nyo siyang ginawang ganito, no? Tapos meron kayong isang value tapos equals this one divided by this one. So you still get n divided by 36 pa. So you get 29.1. Tapos gawin nyo is you do it all over again, no? So baguhin nyo naman to 950. Maging 15.6 siya. Tapos baguhin nyo siya. Or better yet, gawin nyo equals certain cell. Kunwari ganyan. Certain cell dyan. Tapos itong cell na to, babaguhin natin 900, 950, 1050, and tama. Parang ganyan. You can also do this, no? Ito, okay din naman to ganitong strategy. Tapos take note nyo na lang yung number na lumalabas. Pero if you want it to be a table na, mas maganda na ganito yung gawin nyo. Tapos drag down na lang. Okay? So that's for an example of diffusion, no? Na for carburization. Si we I think hindi na natin kailangan i-cover tong ano, no, decarburization because this is just the same, no? Ang difference lang is that and I'll just show how we get this equation. Although I've also explained this dun sa ano, no, audio lecture. So let me show you this one. So how did we get this? So if we did itong CX, ang goal kasi ng ano ng decarburization is that we set the surface. So if this is your ano, no, this is our metal. Kunwari, ito yung metal natin. As we are diffusing a kung ito yung ano natin, diffusion species, then it will diffuse inwards, no? So if this is a concentration of if this is a high concentration, then dapat the diffusion flux will flow from this region to the lower region, which is yung C naught. So this is assuming that CS is greater than C naught, no? So that is the only way for diffusion to occur, parang ganyan. Okay? So in dealloying or yung decarburization or yung si ano, denitrogenization, depending on what diffusing species we are trying to remove, then ang goal natin is dapat si C naught should be greater than CS. And in most cases, gagawin natin tong CS should just be equal to 0. So when CS is equal to 0, then your C naught now becomes the region that is higher concentration. So ang natural tendency na, instead of moving this way, magmo-move this way na yung ano. So that's why madidecarburize, if this is carbon, madidecarburize itong ano natin. Okay? So basically ang ginagawa lang ng ano equation na yung decarburization equation is that gagawin lang natin tong equal to 0. So if we do that, this now becomes CX minus this becomes negative CX over C naught minus 1. Tama? Is equal to 1 minus Earth, and I'll just say Earth Z to now. If this is CX minus C naught, and this is plus 1 na, magiging plus 1 na to, no? Kasi that's C naught plus 1 to kasi negative C naught over negative C naught. So plus 1. So we can cancel this out. Itong dalawang 1 na to. And what we're left with is CX. And we can multiply this all by yung left-hand side and negative, right-hand side by negative para maging positive to, magiging positive din to. So we are left with CX over C naught is equal to Earth Z. And if we further, I don't know, if we oops, further simplify this, we should get Cx is equal to C naught times Earth Z. Okay? So kaya yung sa formula natin dun sa PowerPoint, kaya siya ganyan. Okay, so this is just a simplification of the first na ano natin no case doon, yung case 1 natin doon uh, sa second law, fixed second law. Okay? Okay. So let's ito na bigay na natin. So hindi natin kailangan gawin ito. Let's do example diffusion couples naman tayo no. So diffusion couples occurs when you have two semi-infinite species. So we consider them as semi-infinite para yung boundary conditions natin can be taken at infinity, no? Kahit for all intents and purposes, infinite yung size niya. Pero this is just saying na large enough yung size niya kumpara doon sa infinitesimal na ina-analyze natin na segment when we do the boundary conditions, no? So if you do the solution, you get something that looks like this, no? Wherein the concentration, and this is the concentration at point X at any time T. And for all the fixed law, no, we are always taking the concentration at a point X and at a particular point position X and at a particular time T. Okay, so C is equal to C1 plus C2 over 2 minus C1 minus C2 over 2 multiplied by the error function X over 2 square root of dt. Okay? So one thing you'll notice about this equation is that if you have, for example, gawin natin siyang ano, no? Kunwari lang, okay. Meron tayong ano, no, 2 blocks. Okay, this is 2 blocks of metal. As we place them in intimate contact with each other, usually through welding, no? So we weld them together, and then from the welded part, meron tayong C1 dito and C2. Then they will over time makaka-develop sila ng profile, no? And I think this is shown in ano pala. Ito. Makaka-develop tayo ng profile, no? Something that looks like this. So it initially starts off as a hard na drop, no? Tapos eventually magso-soften yung parang profile niya. And over time, and ito naman yung goal ng diffusion, no, is that over time, if you leave it for a very long amount of time at high temperatures para mabilis naman yung diffusion rates, over time, ang final distribution niya is to equilibrate the concentration across the entire length of the two diffusion couples, no? So similar to how when you have, for example, a liquid na solution of a particular concentration and another liquid solution of another particular concentration, pag minix natin sila, the eventual na final distribution niya will be equal to C1 plus C2 over 2. Tama? So how do we visualize this or compute this value? Paano siya or mag-simplify to this one? Then we just look at, di ba, it's always tapering as we progress with time. Therefore, if we set our time to be infinity, then we should have a value na pag ito, sinet natin to infinity, this is a very large value. So x divided by a very large value becomes equal to 0. So if we take Earth equals 0, that is also equal to 0. No? So this entire term cancels out, leaving us with this one, C1 plus C2 over 2, which again makes sense, no? Kasi if it were to equilibrate, then yung average ng two concentrations nila will be the final concentration of the of the diffusion couple. Now suppose we are interested with at a particular time gusto natin makuha yung concentration at either end um, of the two couples, no? So what we can do is just look at we take this interface here kung saan sila nag-meet. That is where our x is equal to 0. Okay? So we have x, we take x, if x is negative, then we are taking it from this blue end, no? If this is our two couples, no? So we are taking it at the end where the concentration is C1. So anything to the left is etong region na to, etong blue specimen. Anything to the right of x, or that is a positive x value, will be taken at this green na specimen with composition equal to C2. Initial composition equal to C2. Okay? And the good thing about earth functions is that it's symmetrical along the origin, no? So kung yung earth 1 natin kumbaga is just equal to negative earth, or if you take earth negative 1, then that is just equal to the negative of earth 1. Okay? Pero this is useful pagka tabular method yung ginamit nyo, no? But since hindi naman tayo tabular method, Excel ang gagamitin natin, you don't have to concern yourself with this one. No? When you type earth negative 1, it will give you the value that you are looking for. So si Excel na bahala dun. Okay? So let's try an example. Ito, nakita ko na in the ano. Let's try an example, no? Ito, let's try a harder example so siguro. And for this case, I'll use an old exam. This is from 2016. 146 2018 pala class. No? Sana yan? Kaya ito medyo mahirap, no? Papakita ko ba ito? Baka pala i-recycle naman ito. Okay, pwede siguro. So let's do this example. So this is from an old exam, no? So meron tayong laboratory experiment that was designed based on Kirkendall's experimental setup. And if you listen to the podcast, no, you know that Kirkendall experiment is a diffusion couple type of setup, no. So in order to determine the diffusion data for your nickel in copper and as well as copper in nickel, no. So the pre-exponential diffusion coefficient in meters squared and the activation energy in joules per moles. So kumbaga ito yung hinahanap nating values, no? Yung QD and yung D naught. Okay? So two setups were prepared with varying conditions as shown in the table. So ito yung experimental setup natin. Setup A is exposed to 1,000 degrees Celsius over 100 days. Tapos yung setup B natin is 900 degrees Celsius over 200 days. Okay? So yung diffusion couple natin has a concentration profile that looks like this. And distance from initial surface, this is at 1173 degrees Celsius. And this is at 1273 degrees Celsius. Okay? And this is copper concentration from the initial interface. No? Okay, and ito, this concentration profiles of the nickel into the copper at different setups. No? So kumbaga, this is yung 1 minus itong value na to. Okay? Oh no, sorry. This is the concentration profile of the nickel if we analyze it from the interface, no. Okay. So, medyo ano siya, no? mukhang daunting yung task because there are a lot of graphs. But the solution here is not simple pero hindi siya as complicated as it looks, no? So, we do ang gagawin natin is we set up the equations first. So our equation is again yung diffusion couple equation, no? So we have C1 and C2, and since it is when we do these types of analysis, what we want to do is kailangan i-set up natin siya in a way na let me do a new sheet, no? I-set up natin sila in a way that we are looking into one concentration only, no? So we do C naught, and the concentration we are looking for is either hanap tayo ng nickel concentration um, or yung copper concentration. So let's just say nickel yung gusto natin, no? So our concentration is yung nickel yung hinahanap natin. So let's establish that. So if that's the case, then if we do draw the and let's just look at the problem again. Dun sa problem, ang diffusion data niya, para lang we become consistent, no? Dun sa diffusion data niya is that pwedeng sa copper lang tayo tumingin na lang. So sa nickel na tayo tumingin. Ito. This is distance from the original interface. Okay, so to the right. And so parang ano pala to? Kailangan natin i-connect yung dalawang to, no? Yung dalawang graphs na to. Kasi if you imagine this, how should I, parang, let me, para mas ma-imagine kung anong nangyayari. So we have two concentrations. So if you look at kunwari copper concentration lang or nickel concentration. Kung nickel concentration tayo, so if this is the pure nickel, then this is parang we are saying 100% nickel to. So C1 here is equal to 1 or 100. Tapos C2 is equal to 0. Tama? Kasi this is the pure copper side. So ito yung nickel, ito yung copper. Okay? So ito ay 0% copper. Parang ganyan siya. Tapos ang hinahanap natin is ito kasi yung concentration profile niya. Parang ganyan yung initial niya na concentration profile, no? Tapos ang binigay sa atin is over a certain amount of time, nagbago yung concentration, naging ganyan siya. Pero ang binigay kasi is two half data, no? So meron tayong nickel into copper. Tapos meron tayong copper into nickel. Parang ganyan. So ang goal natin is doon sa dalawang data na nakuha natin, i-stitch natin together to form this profile, no? Para mas ma-imagine natin kung paano yung yung kumbaga flow dito. Okay? So, balik tayo sa problem. Doon sa problem, ang sinabi is ilang time to? Duration is 100 days and this is duration niya is 200 days. Okay? So, kailangan natin ng 2 setups. Medyo mahirap pala ito class, no? Pero kailangan natin ng 2 setups kasi to create magiging 2 equations tayo and we are looking for two unknowns kasi yung hinahanap natin, which is yung diffusion pre-exponential diffusion coefficient or D naught saka activation energy. So for us to do for us to find these two unknowns, kailangan natin ng 2 equations, kaya ang binigay is 2 setups, no? One with the varying temperature and duration. Okay? So let's try to solve this. Okay? So hanap tayo ng let's do nickel muna, no? So we are looking at nickel into copper. Both pala yung mahanap natin, no? Yung nickel into copper to nickel. Okay? So Let's use the equation. Equation natin is C naught and switch tayo. Equation natin is C naught, no sorry, Cx minus C naught over, no sorry, diffusion couple pa tayo. So this becomes the concentration at a particular position is equal to C1 plus C2 over C over 2 minus yung C1 minus C2 over 2 multiplied by the exponent ng x position over square root ng 2 square root ng tt. Okay? So let's expand this, no? Ang initial concentrations natin is 100 and 0, no? So let's look at nickel first. Nickel into copper muna tayo. So, nickel into copper, we will have a we can take actually a random point, no, doon sa ano natin. Kasi there are multiple na points naman na binigay. So, right now, hindi ko muna i-state kung ano yung kukunin natin point. No? So, let's just establish this first. Yung, let's just say specimen 1 is the nickel specimen. The specimen 2, parang sabihin natin na yung specimen 1 natin is nickel, is 1. Specimen 2 is the copper specimen. So, if that's the case, then this becomes 100 plus 0 over 2 minus 100 minus 0 over 2 multiplied by xp times 2. Let me just erase this now. 2 times square root ng, and we need to expand pa itong d natin, which is d naught exp ng negative qd over rt. Okay? Multiplied by time. Kasi ito divided by a certain position x. So the way we want to approach this is kunin natin yung kuha tayo ng isang point dito. So this is at kunwari yung 1173 setup, no, which is the 900. This is setup B at 200 days. So ang gagawin natin is this is nickel into copper muna tayo, no. Nickel into copper muna tayo. So ang gagawin natin is kukuha tayo ng 2 points. Let's say start tayo at dito muna, no. 37.2 daw siya at a distance of, if this is 500 microns, then this is around, tingin nyo, copyin ko na nga lang to para mas tayo, no. Hindi pa tayo doon. Okay. Send natin yung board natin. Okay. Ito, kunin natin to. So, ang gagawin natin is, and right now baka na-imagine nyo na yung class, no? Ano yung strategy natin. So, we have 2 unknowns. Ito, we could always fill out one value dito and another value dito based on this graphs, no? Tapos, or based on this, based on these graphs. So, makakuha tayo ng different equations which has this unknown and this unknown as well. Okay? So, ang gagawin natin is we do something like, kunwari, kunin natin to. No 37.2, and this is 250, I'm estimating 252, ito 1250. 125, 150. Tama ba? Or sige, gawin natin 100, 200, 3, sorry. 100, 200, 300, 400. Mga 200 siguro, no? Pwede na siguro yun, 200. This is 200. Sabihin natin 200 to. Tapos ito is, we can take, ito na lang, kuha tayo ng value na sakto dito, no? This is at 1,000 microns. Okay? So ito 200 microns, ito 1,000 microns. So, ito, this is 1173. So, gagawin natin is the concentration at, let's input, no? Let's do at 200 microns, x equals 200 microns. Tapos temperature equals 1173 and time equals, and yung 1173 was 200 days, no? Tama? And just to be sure, balik tayo sa problem natin. It's tama, no? 200 days siya. Okay? So, babalik tayo. We have 200 microns, 1173, T is equal to 200. So, concentration na nun is 37.6. So, input lang natin siya, no? So, we have 37.6 the concentration, and that's 50. So, 50 to, no? Minus, this is also 50. 50 times EXP ng X, which is 200 microns. So 200 times 10 to the negative 3 divided by 2 times square root of, and I could have probably, dapat sineparate ko to. Pero anyway, so this is square root ng D naught EXP negative QD over R, and R is no, so 8.314 multiplied by temperature, which is at 1173. Tama? And time is, this is at time 200 days, and we convert it into seconds. So 200 days into seconds is, malaki, no? Calculate it real quick. 200 days multiplied by 3,600 in 1 hour times 24. Tama ba yung calculation ko? So that gives me 1.728. 1.728 times 10 to the 1, 2, 3, 4, 5, 6, 7. And correct me if my calculations akong mali. So that's 1.728 times 10 to the 7. And this is in seconds, So convert ko yung days into seconds. Hopefully we get the same answer, no? Ito. So notice na dito, this is our first equation. Pero we have two unknowns. So ang gagawin natin is we get another equation. 37.2. Sorry. That's correct. 37.2 lang to. 37.2. So we do another position, which is x at 1,000. And this is at the same conditions, 1173 and t equals 200 days. Then we copy this again. Sorry. Pero this time, ang concentration niya is 5.14. Tama? So, itong value na to, 5.14. 5.14 is equal to 50 minus 50 times exponent. And this is at 1,000 naman. 1,000 10 to the negative 3 position over 2 times ito, D naught EXP negative QD over 8.314 times 1173. Maliit na yung sulat ko, no? Times 1.728 times 10 to the 7. So let's do ourselves a favor and compute muna natin yung constants, no? Para matanggalan natin siya. So if you want to compute the constants, compute natin yung constant natin. So doon muna sa loob ng exponent function natin, no? So we have equals 200. Sorry. Kasi nagbabago to. Sige, okay lang. I-ano natin, step by step natin, no? Ang gawin natin is yung position X and yung concentration natin. So position X natin is 100, 200 microns. So that's equals 200 times 10 to the negative 3. Okay, 0.2. No, sorry. May mali tayo class, no? Dito, microns is, di pala 2 millimeters, no? So if it's microns, times 10 to the negative 6 pa to. Okay? Negative 6 because it's in microns, no? So dun sa Excel, baguhin natin yun. Negative 6 dapat. Okay? So, compute natin yung right-hand side of the equation or itong constant mo na, no? Compute natin kung ano to. Okay? Or, baka pwedeng i-diretsyon type na lang natin. Sige, diretsyon tayo. Meron naman tayong ano, no? MS Math. So, let's use MS Math. Pwede yung i-manual to, no? Pero, I think I can do MS Math dito. Load lang natin yung MS Math natin. Okay. Isa lang muna isosolve natin class, no? Tapos, I'll leave it to you guys yung iba naman. Okay, nakikita ba yung MS Math ko na ano? Nakikita naman. Okay, let's do first solve muna natin yung ano, no, yung first equation muna. So we have 37.2. Medyo mahaba pala to. Okay, we do 37.2 is equal to sorry. Ang kailangan pala natin is end solve, no? But anyway, let's solve for the first one. That's 37.2 is equal to 50 minus 50 multiplied by exponent, which is e raised to the power of, I don't know. Hanapin natin yung e. Wait lang class, hinahanap ko ito, e. E, or baka meron siyang exp. Sana may exp siya na function. Wala siyang exp function. So, mukhang kailangan natin e raised to the power of, let's just say x yung qd natin, or sabihin natin q, negative q divided by, minsan kasi nagloloko si ano, no? MS Math pagka gumamit tayo ng variables na medyo weird, no? So, gawin natin is x na lang. X is the q value, tapos si RT is the sorry. Hindi pa pala. e raised to the power of ito, and again, this will be a long equation, no? Gawin natin divided by, this is 200 microns, 200, and I'll just use the ano na, no? So kung 6, 1, 2, 3, 4, 5, 6. Yeah, tama na ako mag-compute. So I'll just do 200 times 10 times 10 raised to the power of negative 6. Okay? And I divide this entire term. Nope. Ito. Divide natin siya by and this is where it gets confusing, no? Kasi dalawang exponentials na to. Divided by 2 times, yung exponential natin is x for d naught. Yung x natin is the d naught. Multiplied by e. Oh, e. Oh, sorry. That's e raised to the power of negative y over 8.314 times temperature, which is, ano nga temperature nito? 1173. Okay? Tama ba? It looks good to, tama naman siguro, x times e raised to the power of 4. So, okay na to. Tapos, eto, multiply na, square root pa pala, sorry. 2 times square root pa. Square root is here. And lagay natin sa loob tong square root. Itong value na to, lagay natin sa loob. Okay? Square root e. And just to be safe, lagay natin sa loob ng parenthesis to, no? Okay? Medyo ubos na pala time natin class, no? Extend tayo konti lang, mga 5 minutes lang. Tapos times yung time natin, which is 1.728 times 100. And anong ulit yun? That was 200 times, 200 times 36 times 24, no? Ganyan. Okay? Tapos labas siya ng dt. Square root of dt. Dapat nasa loob siya. Okay, may mali dito. Ito, ipasok natin sa loob ng square root. Okay? Separate term naman to. And just to be sure, ilagay ko na lang to sa separate terms. Medyo, okay? I think that's correct. So we have two terms, x and y, and I hope MS Math can solve this now. So we do end solve. End solve, and ano nga yung format ng end solve natin? Mayroon pang isang buray ko na nga lang itong parenthesis. Medyo mahirap siya i-set up class, no? Mag-random na ano dito. Enter. Closing parenthesis. Dalawa kasi. Tanggalin natin. Uh, wait lang. Kailangan kasi i-end solve natin to, no? Saglit lang kasa. Okay, medyo marami tayong kailangan pang gawin pa pala. So I'll probably just show i-send ko na lang yung worksheet ng using Microsoft Math. I-save ko siya sa worksheet para pag sinend ko sa inyo, pwede nyo i-open using Microsoft Math tapos makikita nyo yung sagot. And I'll probably do a PDF file na rin as well, no? Para makita kung paano sinosolve using MS Math itong type of problem na ganito. Pero basically, um, we are pressed for time, no? So hindi na natin masasolve siya. Pero basically, ang ginagawa lang natin is hahanapin natin yung D naught na to. Itong, we have two equations. Itong first equation na to and second equation na to. And we are looking for D naught and QD. So ang makukuha natin dito, itong D naught and QD na to, will be the value of your D naught for the diffusing species nickel into copper. Okay? Tapos yun yung QD then where your diffusing species is nickel, tapos yung host species mo is copper. And we do that steps again all over again for copper into nickel naman. Parang ganun yung gagawin natin. Okay? So I hope that makes sense, no? So this is a more difficult problem pala because this is an exam level problem, no? But I'll probably show the entire solution na lang nito para pwede nyong makita yung process, no? Pero basically parang ganun yung gagawin natin. We are getting ano. Okay. Kervin asked kung bakit 200 to 1,000 yung ginamit natin. So it's really any number, no? You can choose any number. Pwedeng ito yung piliin nyo. Pwedeng ito piliin nyo. So I just chose 1,000 kasi itong 1,000 it falls under a ano no, under a marker na siya. So hindi ko na kailangan i-estimate yung microns. Itong 200 naman kasi ito yung una kong kinuhang value. Yung 200 kasi medyo malapit dito sa ano. Ito medyo mahirap siyang kunin, no, kasi in between siya ng 0 to 500 and if I don't use ImageJ or other software, pwedeng magkamali ako dito sa estimate ko na to. So what I could have really done is just chosen 1,000 and 2,000, no? Kasi si 1,000 falls here. Ito siya. Tapos 2,000 nagpo-fall siya dito. So exact yung values kumbaga. Pero pwede naman kahit ano actually. Okay? Pero if I were to redo the solution of this problem, I would have chosen 1,000 and 2,000 na lang. Kasi again, they fall neatly into a particular na scale, no? Itong 2,000 nagpo-fall siya under dito, tapos 1,000 dito din. So para hindi na ako mag-estimate. Okay? Okay ba 'yon, Kervin? Okay. So we do it again, no, for itong at higher temperatures naman. So we check tapos do it again kung tama. Basically parang ano, no. Actually, pwede ring graphical yung approach natin dito, class, no. So gawin natin instead of solving using MS Math, no. Pwedeng graphical yung approach natin. I-plot natin yung D naught versus QD. Tapos pwede natin siyang ma-solve. And since we're given multiple points, pwede natin siyang ma-solve siya. No? So I'll probably show you a solution for both approaches. No? Yung D naught and ano. Okay? Although I'll have to ask Sir Jolo pala kasi baka balak naming i-reuse yung problem, no? Pero probably not since pinakita ko na sa inyo. So yun lang muna for this session. Thank you again for coming today. And medyo mahirap yung ano, no, lalo na pagka um madami kang variables na na-involved, no? Pero in essence, yung ano naman, diffusion problems, medyo straightforward naman siya. Medyo meron tayong formula, tapos input lang natin yung necessary values para makuha yung ano, no. So how we manipulate the values, the way ang importante lang talaga is to understand kung anong ibig sabihin ng bawat variable. So for example, yung C, this is for a particular X position and for a particular T na component, no. So nagpapahirap lang dito another layer of difficulty is that instead of diffusivity yung binigay sa inyo, you are given the pre-exponential na term and your activation energy. So yun yung isa sa magpapahirap sa diffusion problem, no. Okay? Pero kaya naman natin, no, ma-solve siya. We just need to set up the proper equations. Okay, questions before we end the session for today? Okay tayo? Okay. So with that, thank you for coming in today's lesson. Tapos meet tayo next week na, no? Tapos during the Holy Week, since hindi naman ako magta-travel, you can message me anytime during the Holy Week, no, if you have any consultations. And in fact, if you want, we can hold a parang session during the Holy Week just for review, no? Para consultation lang. So, I can probably do one session. Hindi siya required na mag-attend kayo, pero if you have any questions, then you can attend that session. Tapos, ask away kung ano yung gusto nyong tanungin, no? If you have any problem with any part of the coverage sa LE1 natin. Okay? So, okay ba yun? Okay, I think may thumbs up. Okay, thank you for the thumbs up. Thank you, Kervin, for the reply. So, yun.
Sir, kailan po siya?
Yung parang review session natin.
Review session, sir, yes.
Kayo bahala. Gusto nyo ba 30? Sa 30 natin gawin? Tuesday?
Sila na lang po tanongin niyo.
So,
I'm
pwede
fine
bang
anytime naman po.
ako rin kasi during Holy Week, wala naman akong pupuntahan, no? So, I can do any time. Pwede sigurong, can you come up with a schedule as a batch or as a class? Tapos, I can talk to Sir Jolo as well, no? Pwede sigurong, hindi na siguro. Kasi baka mas mahirap pala yun. So, pwede sigurong as a class, pag-usapan nyo kung ano yung gusto nyong date and time. Tapos, set natin. Tapos, it's probably maybe 2 hour session. So, set lang kayo ng date. Tapos, sabihan nyo ako. Tapos, I'll clear my schedule para sa session na yun. Okay, can you inform me? Kailan nyo ako i-inform? Pwede ba mag-assign ako ng president? Assign ako ng class president para siya yung magre-relay ng information sa akin. Or may gusto ba mag-volunteer? Walang gusto mag-volunteer. Sige, kahit sino na lang sa inyo. Kung if you come up with a schedule, message nyo lang ako, email nyo ako or anything. Message nyo ako kung kailan nyo gusto. Tapos, i-announce ko sa class kung yung final approved na schedule. No? Ganun na lang?
Okay, sir.
Sir,
Okay.
same time din po ba? If ever?
Anytime will do.
Oh, okay.
On my side, no? At least on my side, anytime will do. Wag lang yung mga ridiculous na time slots, no? Like 7 a.m. Yung reason, office hours na lang. Tama. So, anytime during Holy Week. Okay? So, thank you, everyone. Tapos, I'll see you next week para sa review session if ever gusto nyo mag-hold ng review session. No? Tapos, on the 10th, April 10, i-release namin yung exam. Okay? Okay, thank you. And end the meeting na, no? Thank you.
Thank you, sir.
Thank you,
Okay.
sir.
Thank you po.
Okay. Good luck. Happy lunch pala, guys.